Holy crow. It's space weather. There's a coronal mass ejection strike just subsiding as we make the video. Oh my god. By the way, if you're wondering, the sun is not going to kill you. So the first thing we're checking out here is this composite view. 3 different wavelengths. Ionized helium and iron. We see one sunspot growing, but overall a reduction in solar activity. This sunspot down here in the south has grown, and the umbrae are spreading apart from each other. The leading field rotating faster than the trailing field. Besides that mostly stable sunspot group, some degradation in the northern hemisphere sunspots. Here's another composite view. This is a 171 plus colorized magnetogram. Actually, a solar flare happening while we record the video. Actually, while we stream the video live. So, looking at global seismicity here over the past 90 days, an earthquake drought continues. We've seen very quiet seismic 24 hours here. A couple quakes in the mid-5 magnitude range, like this 5.5 at Vanuatu. There was also a significant quake in the mid-Atlantic ridge area. But a very low number of quakes overall on a worldwide basis. Very deep quake there at Fiji at a 4.9 magnitude over 620 kilometers estimated depth. So just scrolling up the list here, a few quakes on the west coast of the U.S. and a little quake swarm there in the Caribbean. That mid-Atlantic quake was a 5.1. Indonesia saw a 5.4. Make that 2 5.4s. So pretty calm seismically speaking, a low number of quakes. The earthquake drought continues. Those end with large earthquakes. Next, looking at volcanoes here briefly. Shivaluch continues to erupt in an explosive fashion, producing a 14,000-foot plume of volcanic ash and a flight level 140 over Kamchatka. Sakurajima continues to remain on the list here, producing an 8,000-foot volcanic ash plume. Please don't pole vault the caldera. Subanosejima, flight level 060 from Subanosejima. And Ibu in Indonesia exploding, flight level 070 from some discrete volcanic ash emissions. Discrete in that they're 7,000 feet above sea level. Tukono exploding, flight level 080. It's an 8,000-foot ash plume. And Popocatépetl appears on the list here. Although volcanic ash has dispersed, it must have erupted briefly in the last 24 hours. Nevado del Ruiz exploding in Colombia. Flight level 220, 22,000-foot ash plume over the South American nation of Colombia. 2 usual suspects erupting in Ecuador, Sangay and Revenador, both exploding. 20,000-foot ash plume over Sangay, 16,000-foot ash plume over Revenador. And to close out our list, we've got Sabancaya producing a 24,000-foot plume of volcanic ash. And once again, with respect to Sabancaya, please don't pole vault the caldera. It could be unhealthful. Now, let's get into our space weather segment, the main portion that we typically cover here at the Smash News Network, Least Busted Name of News. Here's 304 angstroms. And I would note this area up here. We're going to show you a close-up. Once again, we do have a coronal mass ejection strike just subsiding. It was high speed, not particularly high density. It was pretty diffuse. We'll get to it. First, let's take a look at some close-ups of the northern hemisphere. So you see this filament activity right up here. And if you follow us on Twitter, or if you follow the channels that we follow on Twitter, you may have seen some imagery of this. Here it is in some additional composite wavelengths. This is 193 plus 335 angstroms. And some definition of that happening there. So let's take a look at some data from a little closer to home here. The 10.7 centimeter radial flux here only at 114 solar flux units, I think it is. Yeah, 114 solar flux units there, so another decline in the radial flux. Again, solar activity continues to decline over the past few days. That's your 1-year chart of the radial flux represented by that black line. So Space Weather Enthusiast dashboard here showing us the solar wind speed subsiding a bit. Again, we had a high-speed coronal mass ejection strike, but it was diffuse. In other words, not dense. NOAA was right on with the forecast here. Quite accurate, although we didn't quite see a KP6, I don't think. But as far as the timing, pretty well done there by NOAA on that forecast. Next, looking at the magnetohydrodynamic pressure around Earth. And we can expect to see this attempt to reach equilibrium here. Again, we're seeing the subsiding of this latest coronal mass ejection strike. So exciting stuff going on once again, folks. And remember, you don't need to see sunspots or solar flares to see coronal mass ejections. We've been covering them since even before the most recent solar minimum. The solar minimum between solar cycle 24 and solar cycle 25. That's the last 4 hours of Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. This is nanotesla, is the scale represented by the ground magnetic perturbations map. And you can see that coronal mass ejection strike subsiding there based on those ground magnetic perturbations. A little bit more aurora would likely in the southern hemisphere. Unfortunately, it's highly uninhabited. Antarctica is experiencing winter. So you can see we did get to a KP5 there. The planetary K-index is a measurement of global geomagnetism for you new viewers out there. Thanks for tuning in. And we are now in a state of geomagnetic unrest with the subsiding of that coronal mass ejection strike. So the solar wind speed made it all the way up to nearly 700, about 700 kilometers per second there. There's a reading of 685. And you can see a change in the plasma temperature, the solar wind speed, and the solar wind density all at the same time. Also a shift in the BTBZ. The field was pretty strong there at 17 nanotesla on the top pane. We didn't get a super strong negative BZ signal. Otherwise, we would have had maybe a KP6. We just saw a sputtering negative BZ signal, which subsided as well pretty quickly. It was a diffuse high-speed coronal mass ejection strike. You can see the plasma temperature also returning to normal. Current conditions are still quite elevated here at 589 kilometers a second. Solar wind density just below 10 protons per cubic centimeter. And here are your GOES magnetometers. Very low readings here. Low highs and low lows on the GOES magnetometer over the past couple of days. That's your 3 days of measurements from the GOES 16 and GOES 17. Next, we'll look at the current sheet. It's polar. Earth is in a South Pole current sheet shown here in red. North Pole current sheet on the other side of the sun at the moment. No changes expected in that anytime soon. Here's your line of sight field plot. The solar B field, the field that goes through the magnet, this magnet being the sun, represented here in the blue lines. And let's move to coronal holes. So one of the most important features of a solar cycle and its solar polar field progression are those coronal holes. There you can see a bunch of them, all South Pole oriented at the moment. Here's our 193 angstroms wavelength from SDO. And at least one more rather well-defined coronal hole rotating in here in the northeast. Next we shall move to sunspots. So here's a sunspot scenario. We still do have a significant likelihood of solar flares. I would say keep an eye on sunspot 3065. It has grown. And we see those umbrae spreading out. The leading umbra rotating a little faster than the trailing umbra. So don't be surprised to see some flares from that. Also, we have some groups approaching the limb. Sunspot 3062 is only alpha class. Most of the rest are beta class sunspots. Although small, they are capable of producing some flares. So here's your intensity gram, your solar continuum from SDO. Let's zoom in. Some high-res imagery for you there. And again, quite complex are these sunspot groups. This one down here is alpha class as well. There may be a tiny umbra trailing it there. Still barely hanging on to its beta classification, it looks like. Let's move into the realm of flaring. So a flare going on as we stream the video live today. And speaking of live, let's check the life of the stream, and everything looks a-okay. So yeah, a little flare going on at the moment. The X-ray profile has dipped along with the radio flux over the past several days. Here's a 7-day chart just to show you what we're talking about. You can see a background C level X-ray output has now dropped down to a background B level output. So you're at like a B6 X-ray profile now for the background X-ray signal. A great wavelength to view solar flares would be 131 angstroms. This is yesterday and today's imagery. And no major flares over the past 24 hours. Here's another wavelength. We're showing 94 plus 1700 angstroms here. It does a great job of showing you the dark spots of the sunspot umbrae, as well as the light spots. That's the 94 angstroms portion ionized iron. 1700 angstroms is just a portion of the extreme ultraviolet wavelengths. No spikes in the proton flux, no relativistic particles showing up recently. And this morning I stepped out the front door and I noticed Jupiter near its apex of its motion across the ecliptic. We always like to know what's going on above head. That's the current star chart for Lehigh Valley, Pennsylvania, our location. And how about a solar system forecast? We're approaching a new moon. We've got a crescent waning. Let's advance this not to scale model of heavenly bodies 1 week. There's where things will be in a week. We'll be just about a day after a new moon. We'll have a bunch of well-rested reverse werewolves. Next, we'll look at some coronagraphs, and we've got some additional coronal mass ejections. It's becoming a normal thing. And are those earthly directed? Well, we don't think so. That's yesterday's imagery. And here's today's imagery so far. I don't believe there are any additional CMEs headed toward Earth, at least at the moment. Let's take a look at Stereo A and the Soho-Lasco C3 as well. Stereo A is located at this gravitational equilibrium point known as Lagrangian point 5, and the Soho-Lasco C3 is located at this gravitational equilibrium point about 1 million miles toward the Sun from the Earth. That's Lagrange point 1. That's over here. This puts the Earth behind you. And from Stereo A's perspective, Earth would be off on this line. So we pause this here at 2154 on the Soho-Lasco C3, because we do see some ejecta there. And looking over here on Stereo A, we don't really see any ejecta heading down the Earth line. It looks like it may be a little deceptive here, looking like a halo on the Soho-Lasco C3 because of this CME on the far side of the Sun. So we can expect to see additional far side coronal mass ejections today, as this plasma over here will not remain suspended forever. It will either collapse, and likely part of it will eject. Let's let this play through most of these videos here. Don't forget to pay attention to the time and date stamps at the bottom. Those are not synced, but that is the latest data. And of course, Stereo A providing a great check and balance there, because it can be very deceptive when we see coronal mass ejections on the far side of the Sun that make it look like they're Earth-directed when they are indeed not. Next, looking at hydrogen alpha imagery here from the El Teide, Spain ground-based solar observatory, and quite a few filaments on the Earth-facing portion of the solar disk. Huge filament down here snaking around this sunspot. Huge filaments in the northern hemisphere as well. Don't be surprised to see additional coronal mass ejections in the earthly zone. We'll keep you posted on the channel. We've been doing it for over 5 years. And once again, thanks to all of our YouTube viewers, our Twitch viewers, and our BitChute viewers. This is the last about 2.5 hours from the GOES 16 SUVI. And you can see additional instability happening up around this region up here. And we want to get some oohs and ahs, so here is our ooh and ah imagery of the northwestern portion. Some great filamentary activity going on up there. And you can see the size of these filaments with respect to the Earth. Some of those are larger than the entire planet. It's time to go to our bonus features segment, because this video is not over yet. We're going to show electron flux, and we're going to show the total electron content forecast, and even imagery of the ionosphere. So here's the total electron content forecast. We're seeing a little bit more normal electron contents at the beginning, and then some very low electron contents. Check out the low electron content right there. It'll show you the most likely places for GPS errors. Essentially, your GPS is showing you, based on errors, where there are high electron counts. They usually happen around the equator at noon. Things looking a little more normal than they were yesterday. So here is this is just a diagram showing you the altitudes of things like your GPS satellites, the locations of the inner and outer Van Allen belts, and so on. Let's continue on to the satellite's community dashboard. Solar wind kicked up a little bit here in the past few minutes. We do have some satellite charging hazards here, surface charging hazards caused by low energy electrons around places like Mexico and moving into the Central Pacific. We may see some minor communications breakdowns from that. And let's continue on to the electron flux. We're seeing a bit of a cratering here of the electron flux. And again, we are expecting the coronal mass ejection strike that's currently occurring to subside. There could be a signal for a coronal hole high-speed stream mixed in there, so we may see elevated solar wind conditions continue. Here's your relativistic electron forecast model. No arguments there. I'll just leave it at that. That's NOAA's forecast. The green boxes, the yellow diamonds, are the observations. Here's the one-year chart of the relativistic electrons. And let's move to the F ionosphere layer. It's located at about 300 kilometers of altitude. And you could refer to it as the bridge between Earth and space. Here's the vibrational frequency going on up there. And if you're frightened of CERN, please stop. CERN is not scary in any way. It's not going to open a black hole or a portal to an alternate dimension. It's not going to destroy the world or control the weather. It's magnetically shielded. You probably can't even sense CERN being turned on from the surface. So please stop with the CERN nonsense. This is what's going on in the ionosphere. Not what's going on at CERN. Here's the anomaly gram. This is showing anomaly in megahertz from a 30-day median. And it shows you low-frequency anomalies in red, high-frequency anomalies in blue. Here's the current state of affairs at 10:15 Universal Time. That's your ionogram, and there is your anomaly gram. Next, we're going to show the latest intensity gram of the closest star. There's El Sol. That's what's going on. No new sunspots, apparently. And don't be surprised to see flares from this setting area here. We may see some flares or CMEs from this series of sunspots. And this sunspot here has grown in the past 24, as well as showing some divergent motion of its umbrae. In other words, the leading umbra moving a little faster than the trailing one. There's your rock back and forth from your intensity gram and your colorized magnetogram. Let's bring up one more composite. We're going to show Iron Star. That was the wrong wavelength. I apologize. Here's 94, 335, and 193 angstroms. That is yesterday and today. And we'll zoom out so you can see the time and date stamps. And it's time to move to the realm of meteorology. We're not only interested in weather in space, we're also interested in weather on Earth. But before we get there, let's talk about the channel. So, thanks everybody for tuning in. Thanks everybody for leaving comments, etc. We appreciate that. We do read all of our comments, and we try to respond to most of them here at the Smash News Network. Least busted name in news. This video was originally streamed live to Twitch. Twitch.tv/SmashOmash. If you want to support the channel via subscription services, consider becoming a member of the Smash team at the gold or silver subscription level. And if you're not seeing all of our videos in one convenient spot, like on your YouTube feed, click posts from smashomash.com/Smash team. If you're logged in at the gold or silver level, you will see additional content based on your monthly subscription level. You can find links to all of that at smashomash.com, as well as links to our Redbubble shop. And welcome to the Neo Renaissance. Congratulations on realizing the channel exists despite the pathetic censorship of certain large corporations who mislead their investors. Yes, they mislead their investors, which is still a crime even in Banana Republic corporatist plutocracies with two justice systems. Anyway, welcome to the Neo Renaissance. Today's featured product is Mensa. Part of the reason we make these videos is to make Earth not suck again. If you've noticed Earth's been sucking for pushing 3 years, well, there's a lot of consensus around the globe that a lot of bad decisions have been being made to make the planet suck. So it's up to each of you to make the planet not suck. Make Earth not suck again. Mensa. Tell your friends and foes about making Earth not suck again. It's a message of personal responsibility. And here's a message of positivity. If you're going through hell, keep going. Don't pole vault the caldera. And you can find links to our Redbubble shop below the video, as well as on the homepage at smashomash.com. That's our third bestseller. Please make Earth not suck again. Again, it is up to each and every one of you to do so. Press like and subscribe if you enjoy the content. We moved into the realm of space weather because, well, forecasting Earth's weather is just a little bit too easy. So we had to push the boundaries, because if you're not pushing the boundaries, what's the point? So here's our meteorology segment, and we're starting out by looking at Saharan dust. There's some blowing across the Atlantic once again. Once again. Once again, now a loss. There's nothing sucky about Saharan dust blowing across the ocean, though. It fertilizes the Caribbean, making it the lush vacation spot that it indeed is. So let's take a look at ocean temperatures here. How about some sea surface temperature anomalies? We'll show the whole planet. And I won't make any reference to whether or not the oceans are hot or cold. I'll just say that the highest temperatures are the yellow spots, like these areas right here. And oh man, that's well above normal there. And the coldest areas are these light blue spots. 7 degrees below normal there. 7 degrees above normal on those yellow spots. So there's the Atlantic. There is the polar region. North Pacific remaining quite hot. South Pacific remaining quite cold. And there is the southern portion of the planet. We are showing waves there. Let's switch to wind, because it's time. Time to show the jet streams of the eastern world. So there is the eastern world. Did you know that the most people on the whole planet are concentrated in this little small area right here? There are a lot of people in those areas, as that includes India and China. I just thought I'd share. Anyway, that's the 250 hectopascal winds known as the jet streams. Jet streams blowing backwards over the Indian Ocean. Here are the surface winds of this side of the planet. And let us know in the comments if you noticed any huge waves on northeastern Australia We covered it yesterday on our meteorology segment. Here are the surface winds of the Americas. Here are the jet streams of the Americas. Quite a chaotic jet stream here over North America. You can see some backward jet stream here over the northwestern Gulf of Mexico. And we're continuing to see a heat dome, a clockwise rotating high-pressure anticyclone over the southwestern U.S. Most of the jet stream staying north of the country there, although some cold air being injected into the southeastern U.S., it looks like. And here are the jet streams of the central world, Europe, Africa, the Middle East, etc. And we've got a strong anticyclone here off the west coast of Africa. Here are the surface winds of this side of the planet. And let's continue on to blast through our meteorology segment. I learned meteorology by being a cyclist because I wanted to know what was happening on the other side of the mountain, because if it was about to rain on my side of the mountain and I could do a ride on the other side, that would be a reason. So we hope you're adept at forecasting weather. And we've got some severe weather around southern Lake Michigan. Places like Chicago getting kaplastered with lightning, we'll get to it. And lots of heat advisories here in the mid-Atlantic states, as well as the central Mississippi Valley area. If your county's lit, click your county on weather.gov. So again, some strong storms here happening around the southern Lake Michigan area. Also the Carolinas and Georgia seeing some heavy lightning there. That's your NASA GOES lightning mapper. Over the past about 10 hours. And here's a real-time lightning map. Again, Chicago getting kaplastered. Next time you hear thunder, check out lightningmaps.org. You can forecast lightning. You can forecast thunder, rather. Those are thunderclaps that you see propagating. And they can even give you some idea of atmospheric density, because thunder moves faster through high-density air than low-density air. It's just a fact. Remember, folks, the speed of sound is based on pressure. So when we talk about the speed of sound, we're talking about an average atmospheric pressure at sea level. The speed of sound varies based on atmospheric pressure, because sound propagates faster through dense material than it does through diffuse material. Anyway, there's your global view of lightning. Heavy storms there over southern Lake Michigan, and some extra lightning just popping up there while we stream live. If you think lightning doesn't strike twice, it indeed does. So we're going to bring up some forecast models here. These were unavailable when we did show prep, but now they are back. So we're going to bring up the temperature anomaly forecast here from Tropical Tidbits. This is your 72-hour GFS temperature anomaly forecast shown in degrees Celsius. You can see some rather large temperature anomalies here. Not sure if we're still expecting triple-digit temperatures here in Lehigh Valley. Tomorrow, Sunday, that would be Sunday, July 24th. Sunday, July 25th, rather. And let's go back and show the pressure and precipitation forecast as well. This is how we generate these GIFs every day from Tropical Tidbits. Again, that is your GFS 72-hour pressure and precipitation forecast. Some pretty heavy storms expected there in the southwestern U.S. Anyway, continuing on. So severe weather there around Chicago. Let's zoom out to your weather warnings map. Again, if your county is lit, head to weather.gov and click your county. That's from windy.com, by the way, and here is our full 50 states view of Doppler radar vertical motion of water droplets in the air column. Quite a bit of moisture there around the Dakotas and Minnesota, moving toward Lake Superior. Here's your shortwave radiation map showing clouds and fog. And there is your water vapor map. You can see this upper level low, still looking pretty weak. In fact, it's weakened since yesterday. It is rotating counterclockwise, but it is surrounded by dry, massive air, which does not aid to convection. Huge pressure gradients happening in these areas, and cold air being injected into that region is what causes severe weather. Cold air is what causes tornadoes, because you get massive pressure gradients. You get hot, moist air blowing up like this, and you get cold air blowing down like this, and the next thing you know, you and Toto find yourself in Oz. Here's your recap. The U.S. Doppler radar. And let's zoom in briefly here on Chicago. Yowzers. Those are likely to produce damaging wind and hail, possibly. Those are some serious storms. In the windy city, a little windier than normal. There you can see rapid cloud nucleation happening there around the Illinois-Wisconsin border. The water vapor map will show the same. And thanks for tuning in to the composite video. We'll see you soon at the Smash News Network, least busted name in news. And may that solar wind be at your back.